Hello and welcome. Today we're going to pull back the curtain on a secret toolkit that has pretty much powered all of human civilization. We are talking about simple machines, but forget about some dusty old physics lesson. No, we're going to see them for what they really are. Elegant, incredibly powerful tools that are hiding in plain sight all around us every single day.
Okay, so let's just dive right in. To get started, I want you to really think for a second. What even is a machine? Is it always something complicated, with gears and motors and all that? Or could it be something way, way simpler?
Now, seriously, what's the first image that pops into your head? Maybe a car, a computer, some giant factory robot? Okay, hold on to that thought, because we are about to completely flip it on its head.
What about this? A spoon. Just a regular old spoon you're using to pry the lid off a can of paint. You've probably done it a million times. But are you just using a tool, or are you actually operating a machine? Or how about a doorknob? You turn one every single day without even thinking. It feels totally simple, but there's a really powerful principle at work that makes opening a heavy latch door feel like, well, nothing.
And get this, even a needle. I mean, how on earth can this tiny little piece of metal be a machine? It doesn't have any moving parts, and yet it lets you push thread through tough fabric using almost no force at all. So what's the big secret here? It's that a machine has nothing to do with being complicated. As you can see, the real definition is just a device that helps us get work done more easily. It does that by changing either the direction of the force we're applying or the amount of it. And that spoon, that doorknob, and yep, even that needle, they all fit the bill perfectly. Now, to really understand how these little marvels work their magic, we kind of have to learn their language. It's the language of force, and believe me, it only has a few key words you need to know to unlock everything. Here they are, the three main players on the field. First, you've got effort. That's just the push or pull you put in, like you pushing down on that spoon. Then there's the load. That's the resistance you're fighting against, that stubborn paint can lid. And finally, there's work. That's what actually gets done when your effort manages to move that load. See? Simple stuff. This brings us to the magic number of simple machines, mechanical advantage. It's just a way of measuring how much the machine is boosting your own strength. It basically tells you how much help you're getting. And to figure it out, all you do is divide the load by the effort. And here's the bottom line. If that mechanical advantage number is greater than 1, then congratulations, the machine is a force multiplier. It means the force coming out is way bigger than the force you're putting in. You are quite literally stronger with the machine than you are without it. Okay, so let's see all this in action with the most classic, the OG of simple machines, the lever. This thing is so incredibly versatile, it actually comes in 3 different classes, and each one has its own little superpower. At its most basic, a lever is just what you see here. It's a stiff rod that pivots around one fixed point. That pivot point gets a special name, the fulcrum. The real genius of the lever, though, is all about where you decide to place that fulcrum, compared to where you're pushing and what you're trying to move. And this table just breaks it all down beautifully. Just look at the arrangement column. It's all about the order of the fulcrum, the effort, and the load. In a Class 1 lever, the fulcrum is sandwiched in the middle. For Class 2, the load is in the middle. And for Class 3, your effort is right there in the middle. Now look how that one tiny change completely alters the mechanical advantage. Class 2 is always a strength booster, but Class 3, well, that one's trading strength for something else. The seesaw is the absolute perfect example of a Class I lever. You've got the pivot, the fulcrum, right in the center. The load, your friend, is on one end, and your effort is you pushing down on the other. A crowbar, a pair of scissors, they work the exact same way. A bottle opener is a classic Class 2. The very tip of it on the edge of the bottle cap, that's your fulcrum. The cap you're lifting is the load, and your hand provides the effort way at the other end. Because your effort is always farther from the fulcrum than the load is, this class will always make you stronger. And then we have Class 3 levers, like a pair of tongs, or even your own arm. Here, you apply your effort in the middle. So the mechanical advantage is always less than 1, meaning you're not getting any stronger. So why would you ever use it? Because you're trading that raw power for speed and range of motion. A tiny squeeze on the tongs creates a huge, fast movement at the tips. It's a trade-off. Now, the lever is fascinating for sure, but it's just one member of this awesome family. The other simple machines are all just really clever variations on a few fundamental ideas. Let's start with the inclined plane. It's just a ramp. Instead of trying to lift a super heavy box straight up, you can push it up a long, gentle slope with way less force. You're just trading a little extra distance for a lot less effort. Think of any ramp or even a staircase. Okay, now get ready for one of those great aha moments. What is a screw? It's nothing more than an inclined plane wrapped around a cylinder. Those threads are just a tiny continuous ramp that takes a small turning force and converts it into a massively powerful forward driving force. Isn't that cool? And the rest of the family just builds on these ideas. A wedge, like the head of an axe, is basically just two inclined planes stuck back to back, perfect for splitting things apart. A wheel and axle, hey, there's our doorknob again, uses a big wheel to make turning a small rod super easy. And a pulley is just a wheel that lets you change the direction of your force, so you can pull down on a rope to lift something up. The most amazing thing about all of this is that once you learn this secret language, you can't unsee it. Seriously, the world around you just transforms into this living museum of incredible human ingenuity. This quote really just gets right to the heart of it all. These simple devices, they empower us. They let us apply force in smarter, much more effective ways. They let us overcome our own physical limits and literally build the world we live in. Every single time you twist the lid off a jar, that's a screw. Every time you walk up a flight of stairs, you're using an inclined plane. These aren't just little household tricks. They are the fundamental building blocks that allowed us to build everything from the pyramids to modern skyscrapers. You are constantly surrounded by these brilliant solutions. So I'm going to leave you with this final thought, this little challenge. From the second you turn the handle on the faucet in the morning to the moment you use a knife to butter your toast, you are interacting with a whole symphony of simple machines. So the question is no longer if you use them, it's how many can you spot? Go on, start looking.